Hi, I'm Dan Linstead. Welcome back to part 4, Data Lakes versus Data Warehouses in the Defining a Data Lake series. I think it's important that we talk about these things before we ask the question, can a data vault, data warehouse, be in a data lake, right? So let's take a look at the original definition of data warehouse, a subject-oriented, integrated, time-variant, non-volatile collection of data in support of management decision-making processes. Now that's from Bill Inman. I like to say integrated by business key, which Bill has supported, and detail, raw, and granular. Otherwise, auditability is out the window. I like to say time variant by delta-driven processes. That's usually what it means. But time variant doesn't necessarily mean you have to have delta-driven. You can have time variance with snapshot-based data. But I do find it interesting that this definition says absolutely nothing about structure. It says nothing about structured data only, or unstructured, semi-structured, or multi-structured. So this raises the question, how do we define a data lake? Well, let's go back to the definition that I personally like from Tamara Dahl. A data lake is a storage repository, holds a vast amount of raw data in its native format, including structured, semi-structured, and unstructured data. Data structure and requirements are not defined until the data is needed. I agree with this. So that gives us the notion of schema on read. Okay, wonderful, right? But there's not a lot of difference between this definition and the definition of a data warehouse. So let's go to a chart that my good friend Tamara put together that's also a part of this article. And the industry has latched on to this article from 2015 and sort of said, okay, this is how we define a data lake. And they marched along and said, hey, we are in full agreement of this. And I tend to disagree. So if you look at these things, the definition of a data warehouse never said anything about data processing, storage, agility, security, or users. Sorry, it didn't. It really didn't say anything about that. It didn't say you had to have structured or unstructured data, or didn't define schema on read versus schema on write. That was never part of the original definition. So I struggle with this chart, and I struggle with the way the labels are on this chart. So let's take a look at data lake versus data warehouse and take another look at this chart from a different perspective. I believe we're asking the wrong question. I don't think it's data lake versus data warehouse for this chart. I think the labels are wrong. I think all of these components, data processing, storage, agility, security, and users, those are all platform decisions. So what's changed is the technology and the capabilities. When you change the labels of this chart, all of a sudden, at least to me, it makes a lot more sense. Traditional relational database management system or platform, Oracle, SQL Server, Sybase, DB2, MySQL, Postgres, all these kinds of things, structured and processed. I get it. All those relational database management solutions forced us to define table structures before we loaded data. Schema on write, yeah, that's part of it. Expensive for large data volumes. Well, of course, that all depends. Even today, the cost of storage is coming down leaps and bounds. So you have to ask the question, by what gauge are you trying to measure cost, or how is that related to agility? What is agility? Now, with the data vault model in a relational database management engine, we have increased agility 100-fold or at least 50-fold. Take a look at Warescape and the results of the build out following Data Vault Express, or Analytics DS and the results of automating the process of data warehousing. So agility, well, agility can be argued in a methodology. So it really doesn't have anything to do with this component. All these about the physical technology, they have nothing to do with the data warehouse. So where does that leave us with data lake versus data warehouse, right? So I'm going to go back to the original definition and make a different comparison chart here. So the original definition of data warehouse, well, could you include storage repository? Yeah. Absolutely, you need some form of storage repository to integrate raw data sets. Vast amount of raw data. Well, we used to call that very large databases. Then it became very large data warehousing in the 90s, and nowadays they call it big data. Pretty soon they're going to call it extreme data, or whatever the new buzzword of the day is. But yeah, I've been doing, in 1997, I built 15 terabytes into a Sybase system. That was a lot of data. Granular, and of course native format. Here's something else we did. My team built an image processing extension in C++ for Sybase in 1995. Granted, they were black and white image drawings, but we still processed quote-unquote semi-structured or unstructured data content, i.e. blobs, inside of Sybase for analytical purposes. Right? Original definition says nothing about schema on read versus write. Subject-oriented. Okay, great. So the data lake's not subject-oriented, not integrated. So logical data warehouses can be physically implemented anywhere, including on the new NoSQL and NewSQL platforms. So you have to be very careful with how you define your data warehouse, right? That's my point. So let's summarize the differences and get to answering the question. So meaning, I think we've been asking the wrong question all these years, which of course leads us to the wrong answer. The wrong question, is a data lake a data warehouse? I don't think that's the right question. I think really, if we take a look at data lake versus data warehouse, from a purist standpoint or from a definitional standpoint of what the differences are, this is what we find, right? Subject-oriented, integrated by business key, time-variant. Okay, great. So in a data lake site, not subject-oriented when ingested. Okay, what happens when you process the data, whether it be through a virtual engine or through Hive or through some analytical process? Well, then it becomes subject-oriented, doesn't it? And at that point, when you process it in a data lake or a landing zone, all of a sudden you have to apply structure to it. Who cares when it happens, whether it's late binding or not, whether it's schema read or schema on write? You have to apply structure, right? Not integrated at all. Well, the original ingestion of a landing zone is not integrated at all. But does that mean a landing zone is a data lake? Maybe. Depends on upstream CDC. Time variance. Interesting question. You can have time variance without change data capture. You can take snapshots of data sets and you can do the delta processing on the snapshot level if you want. And it turns out that a majority of systems try to do that today. It is, however, more cost effective, and I've proven this over the years in just about every client I've worked with, to do the change data capture on the source systems. So finally, a comparison that I understand. These are the true differences between data warehouses and data lakes. Now we get to ask the right questions. Can we build a data warehouse in a data lake? Of course we can, right? Should we build a data warehouse in a data lake? The answer is it depends. If all you're trying to do is data science work or investigative work or things like that, then probably no, you don't want a data warehouse. But if you need structure, if you need analysis, if you need multi-integrated systems or multiple systems from around the world, integrated by consistent business keys, if you need to tie your data back to the business process by business key, then yeah, you should. So can we leverage an existing data warehouse in a data lake? Yes, I've got lots of customers doing that today. This is the best practice, by the way. Don't throw the baby out with the bathwater and just get rid of your data warehouse just because you're implementing Hadoop or a data lake, as the case may be. Do we need a data warehouse if we have a data lake? Different question. The answer there, it depends. If you already have a data lake, again, if all you're doing is data science work, probably not. You don't need to go build a data warehouse if you don't have one. But if you need analytics and integration and everything else, then yes, you need a data warehouse. So these are the things that we talk about. Thank you for watching in this video. If you like this style of training, by all means, check out Data Vault certification and check out learndatavault.com. We have high quality training out there as well. Hope to see you in the next video. Take care.